tags on Chinook salmon.
Thank you. I'd like to update you guys on a project we've been doing for 2 years now, and it's based on using technology used in marine settings often, a pop-off satellite archival tag, and our study animal is Chinook salmon in Lake Ontario. And this is the tag hanging off; it's externally attached. It is funded by New York Sea Grant. So these are the charter boat captains that helped us out in the past couple of years. This past summer, we actually worked quite a bit with GF charters out of Oswego. And a big focus of the project is to both utilize their knowledge, acquired knowledge, and then give back with what we find scientifically. And then I'd like to give a shout out to Jesse Lepakand, who was the extension person from Sea Grant within the project. And he did a great job organizing videos and communicating knowledge back to the stakeholders. So we all know that this is a non-native species, but it's been stocked over time since the 60s, and it's become a very important economically and culturally part of Lake Ontario right now. There's two different components of it. There's the July-September lake fishing, and then we also have when the fish spawn in the tributaries, we have that river-based fishing. But this is just a short summary of 2017, which was kind of a poor year because of high water levels, but exceedingly a lot of trips involved here. And there are basically looking at Chinook salmon in the beginning of their lives and at the end of their lives. One very neat study has been the coated wire tag studies that happened between 2010 and 2013. And that was really crucial in documenting the sources of the stuff, where the source and dispersal of these fish. And there is naturalized reproduction as well. And then at the end of their life at the hatchery or through angler surveys, they summarize the size and condition of mature adults. One observation that kind of fueled this study was looking at hydroacoustic of alewife, which is their main forage food. And what we see through hydroacoustics, usually we do night surveys of abundance for alewife, and at that time in the summer in Lake Ontario, they're very dispersed throughout the upper water column in the warm water. But during the day you get schooling, and so this actually transitions that night to day sequence. And these are often called by charter boat captains bait balls, and they search them out and use them. So we wondered, we had a few questions. So some were, how do Chinook, do they follow the alewife prey in kind of a diurnal migration? And we know that they really respond to temperature well. They need cool temperatures, so that's, we definitely expected to see close ties to that. And then how quickly do they change? Lake Ontario is very dynamic, hydrodynamically, so how do they respond to quick changes? And then how do they stage as they approach the tributary? These are the pop-off satellite archival tags. So they pop off the fish at a pre-programmed time. There's two different brands here. Wildlife Computers is definitely my favorite. They either use a pyrotechnic, like explosive force, to let go, or Wildlife Computers developed a prototype of a copper corrosion process that works in marine systems, but for fresh water. Now, they have these long antennas, and they're about the size of this microphone. The antenna is able to transmit the position and also some of the data that they've collected to an Argos satellite. And then there's several sensors on each one, as well as a battery pack, so they can collect data of temperature, depth, light levels, acceleration, and one even does a magnetic field. And they can store these for up to a year. So these are just some pictures from our angling of the fish, and then applying the external tag with 200-pound monofilament as a harness, and then putting it back in. We did kind of use this recovery period, which was very helpful to ensure that the fish were viable before committing to a $5,000 tag. These are two examples from this year showing very quick recovery. So this is in 200 meters of water. Because we had it on the harness, it was time enough for the tag to kick in. So you actually see that is when we let go from the quick release. And the fish, the color is temperature, so the fish was able to regain its preferred habitat in a relatively quick manner, 100 seconds or 300 seconds. There have been mortalities, and even these are somewhat instructive. This is an example of a fish struggling and then finally flatlining, and in a relatively shallow place, and you can see incredible variability in the bottom temperature, but very stable. And this little red line is the time when it popped up. Now in a deeper setting, this is in 70 meters of water, we had a very important thing for the vendor, and that is that there's a considerable delay. It's supposed to let go within a day of being still, and this took 46 days because of the cool temperatures. So definitely something the company is very interested in improving on. At least it did pop off eventually, but it's a problem. These are some of the routes that we've had for successful tags. And it's much like the coated wire tag data show that there's a great diversity in sources and the spread of where the fish go. And there's one out there right now that it's a little bit younger than a lot of the mature ones we put out, so I'm really hopeful that it goes throughout the whole winter. And then there, the different brand out of Braddock Bay, we did 2 more, and they also go to places like the Salmon River and Coburg Creek on the other side. So this is I presented this last year, the fish that went from Oswego to Coburg, and this figure just shows that it really is important to get the tag back because you have incredibly more of the data. In marine settings, they tend to use this kind of data because they just don't get the tag back. But it really helps us in this case to get the full time series. You can see the difference in resolution. So zooming into this figure, so we have a series of very high frequency forays into the shallow water, but mostly the fish is at thermocline. It is very dynamic over the 6 weeks. And then there are a series of deep dives, some as deep as 100 meters. Now, during August 6th to 11th, something happened. The fish was pretty close to the surface, but then went back deep. And then at the end, it's staging at the tributary near Coburg Creek in Ontario. Zooming into these short-term events, you can see the upward forays go to the surface, and they're only 2 minutes long, very rapid. And then the dive, so this is a dive down to 100 meters, and very quick, rapid descent, but then worked its way up over 20 minutes to get back to its preferred temperatures. So these were really exciting, but you do have to have really good temporal resolution to be able to capture these. So as far as that cool period of time when the fish is at the surface, this is what happened between August 6th to 11th. You see this large section of cool water on the north shore. So that helped us confirm that that fish is in that upwelling area, which is a common occurrence, but very short term in Lake Ontario. These are temperature and depth histograms of the entire trip, showing that there's a pretty unimodal distribution of temperature, a little warmer than we might expect overall, and then several modes of depth due to the hydrography. One fascinating thing is that the salmon actually act as temperature profilers, which kind of beefs up our sampling on very expensive boats. So these are 3 different days of what the fish experienced. And in 2018, we actually had a glider, two gliders deployed because it's an intensive year for Lake Ontario. So this was put out in the lake and followed this path. So we have really good index of the temperature profiles. We hope to link that up to the salmon data this year. So we're trying to answer our question, is there day-night changes? Looking at a couple days from last year, you can see that very consistent depth distribution. The depth is on the y-axis, and each of these are single days in succession. But there are short-term events that are very important. So one way I figured out how to plot this to get this across is using the light meter data on the fish. So each of these is the same 2 days. And the color in this case, instead of temperature, it actually is the depth. So blue would be a downward dive to 30 meters, whereas red is an upward foray. And this is the day-night cycle. So what it really confirms is that many of the upward forays are really happening on the late afternoon sunset. And then a lot of the downward dives are happening in the late afternoon. So pretty cool that things are lining up like that. And the light meters are very sensitive. I mean, this is showing the reason why you have these short-term blips is because it's going up in the water column at night, so it's actually able to pick that up, the light changes there. So showing some fresher 2018 data. One neat thing that we did was we actually had 2 fish tagged within an hour of each other appear at the Oswego River Dam within a day of each other. So they spent a month out in the lake and then came in, which is pretty exciting. It's nice to have more than one individual to kind of follow that. And then another fish went all the way to the Niagara River, which was very exciting. And so that one also was about a month. So zooming in, the Oswego River has a dam right in downtown, which is a very popular salmon fishing spot. One of my tags was actually the fish was caught, and the fisherman reached out to get the fish and saw this space age tag on it. Ended up losing the fish, but kept the tag. Then the other one had to cross the river at kind of relatively high flow and find it on the other side, so that was an adventure a little bit. But these are the 2 time series for these 2 fish. And you can see some differences, but there are this area pointing out, again, a cool section at the surface. And then you can notice that the staging is relatively warm, but the fish are acting very differently. They are slightly different resolution differences, but very much deeper for the second fish. They're very similar size. And so in this case, we actually had upwelling on the south shore instead of the north shore, so the fish were able to pick that up this year instead of, in the other case, it was on the north shore. And that's just due to the different wind directions. And as far as staging, this is the temperature probe at the Oswego River, and the black line represents when the fish entered. So you can kind of see they're really lined up for when the temperature got down to 20 degrees Celsius. So really good pinpointing of when the fish is entering the river. These are the temperature distribution histograms and depth histograms. So you can see some difference, even warmer for that fish one. And kind of zooming of each of these are the 2 different fish over 6 or 7 days. So pinpointing a little bit different behavior from that last one I showed. There's some morning forays here, and there's some afternoon and night forays here. This red indicates where the fish was up at the surface because of the cool water, so that's why it's there. This is the Oswego to the Niagara River over the month of September. So again, this one also captured that cool water scene. It also went back down deep and did some more dives. And then as it worked its way west, so we should be able to track the thermocline depth. It usually shallows as you go west. Exciting thing about this is we actually had we've added an acoustic tag on these fish. So we hope to use that as an occasional fix. And Niagara River, which is where the tag was found, is a perfect place in Lake Ontario to do that. So Dmitry Gorski thinks that we might upload the data in the spring, and we might actually have that fish kind of pinpointed a little more. And just wrapping up, these might have importance for bioenergetic models. The dash line represents the 11 degrees Celsius used by Stewart and Navarro back in 1991 for Lake Michigan. And the fish initially was, these are the 3 fish that I just presented for 2018. They were again kind of near the 13 degrees Celsius. They experienced very cool temperatures during that upwelling event. And a lot of times those upwellings are also low in alewife, so that's kind of stressful for the fish in the summer. But as we worked our way towards the tributary, you can tell that the temperature is going much higher than we would expect. So we want to figure out like where's the activity versus the like stopping feeding and entering the tributary. So, but this has some implications that there's more consumption than we might be estimating for salmon in Lake Ontario. And so to conclude, Chinook are very well suited to this type of technology. They have very wide vertical distribution, and they also follow that temperature at the base of the mixed layer very well, and they have the behavior, very short-term behavioral excursions. You really need the temporal resolution fine enough. And I'd just like to thank all the assistants from this past couple of years, which is a pretty good gig, I think. They enjoyed it. But thank you for being a great audience. Thank you.